My name is Fabiola Gianotti, and my project was the Higgs Boson experiment. I was the main project leader for ATLAS, which was one of two of the Large Hadron Collider experiments involved with the observation of the particle at CERN. In the 60s, physicists noticed that there were interesting connections between the weak force and the electromagnetic force, two of the fundamental forces in our universe. These connections implied that electricity, magnetism, light, and some forms of radioactivity are manifestations of a singular force known as the electroweak force. Basic equations accurately described the electroweak force with one major issue. The particles associated with this force, the photon and W and Z bosons, all emerged without a mass. Robert Brout, Francois Englert, and Peter Higgs theorized that this was due to an invisible field called the Higgs field. This field permeates our universe and gives mass to any particle that interacts with it. It has grown significantly since the Big Bang, and any particle that doesn't interact with it, such as a photon, would not gain a mass. Higgs, Englert, and Brout also theorized that this field, as all other fundamental fields, would manifest as a particle. Unfortunately, no other experiment had ever observed such a particle, so we set out to find the Higgs boson. We wouldn't have any luck until 2011 when we observed a small blip in our data of excess Higgs decay. The existence of the particle would then not be confirmed again until 2012 when we produced the same blip. We started conducting our experiments in the 80s with the Large Electron-Positron Collider at CERN in Geneva. However, it wouldn't be until the completion of the Large Hadron Collider in 2011 that we actually had a machine that was powerful enough to possibly produce the Higgs boson. 10 days after the LHC was operational, it took significant damage and was shut down for over a year. One of the biggest news stories during our run of the LHC was that Osama bin Laden was found and killed. Coincidentally, in the science world, another groundbreaking physics experiment was taking place at CERN called OPERA. This experiment tracked neutrinos traveling from Switzerland to Italy, a handful of which made the journey a mere 60 nanoseconds faster than they were expected to at the speed of light. The scientist that started this all was Peter Higgs. He began his work when he started to wonder where mass comes from. Higgs and his colleague Francois Englert won the Nobel Prize for the discovery of the boson. Their other collaborator, Robert Brout, was originally part of the proposal for the Higgs field, but sadly he passed away in 2011 before the particle's discovery was actually confirmed. I was elected to be the spokesperson and lead coordinator for the ATLAS experiment at CERN in Geneva from 2009 to 2013. I was responsible for over 3,000 scientists working on the Higgs boson project. My main role was to lead my team in the planning and execution of the project, then present the findings to the media. I led the seminar that announced the discovery of the particle on July 4th, 2012 in Melbourne, Australia. The Higgs boson is believed to be a fundamental building block of our universe. Its discovery has helped us further understand the nature and origin of our universe and may even continue to do so. Like some other physics experiments, the existence of the particle didn't break any grounds or destroy any previous thoughts that we had had, but more have helped us put a piece into the puzzle that we were already working on. The Higgs boson may even continue to help us understand how dark matter works in the coming future. Since January 2016, I have been the Director General at CERN, the first woman to ever hold the position. The LHC is currently shut down for upgrades to its accelerator complex, and we are set to resume the experiment in 2021 with higher intensity beams. By 2026, we hope to have the collider ready for a high luminosity phase, in which we believe that we will be producing a large quantity of Higgs bosons each year. CERN has also put forward plans for a larger collider, which would be a $20 billion endeavor. We hope to use the new collider to further understand the workings of our known universe, including dark matter.